So good morning, friends. This is Durga again from IT University. So at this time, we are talking about scoop export. So far, we have covered starting from setting up the development environment to MapReduce overview, Spark, and Hive. And at this time, we are talking about exporting data from HDFS using Scoop. As part of the last class, I have explained how Scoop export works. It uses the HDFS native feature of blocks and splits to determine how to load the data into from HDFS into the database. Okay, so we'll continue wherever we left. We'll be focusing on 1 minute. Let me make sure that guys on YouTube can see my screen.
Goodbye.
1 minute.
Goodbye.
Yeah, so they can see the screen. Okay, so let's move on. So at this time we are talking about scoop export, and so this is how a sample scoop export command looks like. So we have username, we have password, we have table, we have export directory, and then there are these two fields called input fields terminated by and input lines terminated by. I haven't covered what they are. I will be covering in a moment, and the number of mappers, output directory, etc. So now let us go to Scoop user guide and try to understand these uh, control arguments for delimiters. Okay, rest of the stuff I hope you can recollect. So connect is to just pass the JDBC URL with the database name, username, password. They are explanatory. Table is the target table to which we are trying to load. Export directory is, uh, we need to give the location of the directory from which we want to copy the data. And if you see here, I am trying to copy data from a table called departments uh, in a database called retail underscore ODS. If I have my database and table in that format, it's actually Hive table. But as we cannot pass the Hive table at the time of export, we have to give the directory uh, in HDFS to which Hive table is pointing. And then I will cover the input fields terminated by and input lines terminated by. So if you go back even to the scoop import syntax, okay, if you go to the scoop import and if you scroll down a little bit, so these are the main import control arguments where we can, let me mute. I'm not even able to mute. Yeah, now it is better. I don't know. WebEx WebEx sometimes behave weird. Anyway, so if we scroll down, controlling parallelism after incremental load file formats. This is the one. The fields terminated by and lines terminated by. So yeah, at the time of import, you can specify how the fields are terminated or how the lines are terminated by passing these two parameters. This is for scoop import. When you do the scoop export, the counterparts for these commands will have a prefix called input. So for fields terminator from HDFS into database, we use input fields terminated by. For lines, we use input lines terminated by. So these two are used at the time of scoop import, and these two are used at the time of scoop export. So typically we have to use these parameters because if you understand the delimiters for line, its new line character. Actually, this should be /n, but when I actually save the code snippets in my WordPress plugin, it removes those slashes. So I am trying to figure out a way so that I have valid code snippets. So I'm planning to revamp my website, and I will take care and come up with a much better design than this. Anyway, that being said, here for new line character, Hive and Scoop uses the same terminator if it is text file. So we don't need to much worry about lines terminator. But when it comes to fields terminator, there is a difference. The default terminator for Scoop is comma, and the default terminator for Hive is null character. So they both have to match. So either you have to first do the Scoop import with default delimiter or whatever delimiter you want, and then make sure you have Hive table with the delimiter used in as part of the Scoop. So in Hive we have row format delimited fields terminated by. At the time you have to specify what is the delimiter you will be using while loading the data. So both Scoop and Hive have to match if you want to process the data using Hive downstream. Okay, and then once you have data in Hive, if you have to export into a RDBMS database, or even in any, not only Hive, in any HDFS location, you need to make sure that the specification for the fields terminated by matches between Hive and Scoop. That is the most important thing. Otherwise, you will run into weird issues sometimes. You have to be extremely careful when you are using multiple tools. You understand the dependencies and you work on those dependencies so that they work without much issues. Okay, so now let me demonstrate how to do it. So I'm connecting to CloudX Lab. Okay, and then I will use Hive table itself. There is the reason why I'm showing Hive, and I will explain a little bit later. Okay, and the same principles apply even for regular data also. In this case, I am just using Hive table to export, because we try to build an end-to-end application using Hive and Scoop in conjunction. They both have to work together. That's why I'm emphasizing a little bit on Hive, as you already know about Hive. Okay, so I'm launching Hive. So you have to go through these steps before coming up with the Scoop command, and then automate using that Scoop command as template. So the first step is go to Hive, understand your table. So I have database called training 8634. When I run show tables, it will list the tables. So in this case, I will be exporting this departments underscore piped. Okay, so let us see that it have data. It has, and let us understand the how the data look like. So I'm running dfs -cat, because I can also say describe formatted. The main idea is to get the delimiter. Describe formatted departments pipe. You can see that delimiter is pipe. We can also do dfs -cat apps Hive warehouse planning 8634.db pipe So this is another way where you can actually look into the data. Let me do this. So you can see that delimiter is pipe. So we need to use this one while doing the scoop export. And even though it is a Hive table, we cannot pass on the Hive table while doing the scoop export. We have to use this path if you want to export the data. Okay. So in this case, as we don't have multiple databases, we are using same MySQL database which we have used earlier to demonstrate this one. Typically in production environment, the source will be different and the target will be different. And while loading the data into the target database using scoop export, typically we apply all the transformations, denomination, aggregations, joins, whatever transformations required, those will be applied, and you will get the output, and you have to export that output into a downstream database which will be supporting your reporting layer. Okay, so source database and target database will be typically different, but as we don't have multiple environments, we are using the same source database as the target database itself. So I'm exiting from here. We understand how our data look like, what is the location of our data, and now we need to make sure we have the table. Okay, use retail underscore DB, show tables. Okay, so we have a table called departments here, but there is no table with name departments underscore piped, and I want to use the same table name as in my Hive for this table. That's the standard practice. Whatever final table you want to export, that table and in Hive, and the table which you will be importing in or copying in MySQL, the target table should match. That way it will be a little bit easier for you to automate. Okay, so here I am creating table departments type. It's only best practice. There is no requirement that it has to match, but it's only best practice. So here it will have two fields: department ID, integers, department name, varchar of 50. Okay, now the table is created. You can then select to validate that. So there is no data in this. Now I am exiting. Okay. And now we have to run the scoop export command. So these two lines are okay. Here we have to change the host name. EC2 internal 3306. So 3306 is MySQL port number. It's a default port number. If it is 3306, you don't even need to specify the port number. But if it is not 3306, it is mandatory that you have to specify the port number here. So it's better to have port number all the time, even though for 3306 it is not required, as you are not doing it on day-to-day basis. To just remember the syntax for certifications, etc., it's better to give the port number all the time. Okay, and then retail underscore DB, then username retail underscore DBA, password university, and table to which I want to copy is this new table, departments underscore piped. And export directory. Whatever location and the table is pointing to in HDFS. and then we have to say input fields terminated by input lines terminated by. It is not required because Hive and scoop default input line is new line character only, so you don't need to specify this. I think I have to give the single quotes. Probably it might work with the double quotes also. Let us see. If it failed, then most likely it could be due to single quotes here. Okay, and then you can specify the number of mappers for larger tables or larger data sets. In this case, I'm specifying it as 2. Hit enter. Now the scoop export will run similar to the scoop import. First, it is going to the target table to determine how the table look like about the data types and all, and then it will generate the MapReduce code to read the data from HDFS based on the split logic and write it into MySQL database. So it is successful. You can see map input records are 6 and map output records are 6. Typically, scoop is map only. There won't be any reducers, both scoop import and export. So it worked fine. Okay. So the way we can validate is now by connecting to MySQL. Or we can even use scoop eval command to validate. Okay, so now you can see that there is a data. So now the most important question when developing an end-to-end application, a data integration platform, to get the data from the source database, have the data store it in HDFS, use MapReduce or Spark or Hive to process the data, and export data back to a target database from where reporting happens. So this is called as workflow. You have source systems from which you need to get data, and you have to make sure you get all the data required to do the downstream processing. For example, if you have 2 tables that needs to be joined, one table can be copied in few seconds. Like departments is a small table, so it can be copied very fast. But when it comes to transactional tables, it will take time to load. So until both the data sets that needs to be joined as part of the data processing layer is done, you have to wait. Okay. Once you get both the data sets, then you have to execute this data processing logic to join the data set, apply the aggregations, etc. The way we have done in Spark. And once that is done, the data has to be stored into HDFS back again. And then it has, if it is Spark, you can use Tableau to report out of Hadoop directly using Spark connector. If it is not Spark, even in some cases, if you just want to use your enterprise BI tool with all capabilities, then probably you might have to have a lightweight reporting database, which will only store the data that is used for the reporting layer. And for that, you have to do the scoop export. All this is called as workflow. Okay. And that's where tools like Oozie, or you need to build a complete end-to-end application in such a way that they all work together. One of the standard requirement to load into this target reporting database is to capture the delta. For example, let's say there are few new department added in the source. So our source database is this retail_db itself. And let's say, and actual table is departments in the source. Let's say a new department is added. Okay. We have to, and also there are several transactions on the existing departments and also for the products in new departments. So when we get the data and when we process and when we load into the target table, we need to capture delta. Okay. and we have to load only, for departments we have to load only one record, which is 8, and whatever department name it is, we have to load into the our target reporting layer. We need to add this one additional record. So when it comes to scoop export, the caveat is you can only use export directory and you can only give the HDFS path. Okay. So if it is the partition table, and if the delta is always captured in partition, then you can give the HDFS location of the partition and the export will be done. That is one strategy. For a very large table, if you have to capture delta, and if it is only insert mode into the target table, um, or even if it is not insert mode, if you can logically separate the delta into a partition, if you have enough data volume, then you can create a partition and you have to export from that partition. Okay. Again, to create the partition, you have to use Hive. Okay, Hive or some other processing tool, and make sure that the delta is in a different partition to export the data. Otherwise, you have to create a new table in Hive or new directory in HDFS to capture the delta, and from that you export it. So you always have to use a data processing tool such as Hive or Spark to capture the delta, and then you have to use scoop export to export the delta into the reporting database. There is no out-of-the-box solution from scoop itself to capture the delta in a Hive table or in a Spark. Even if you are using Spark for some reason, there is no way to do. Just use scoop and get the delta directly and load into the target database. You have to first process the data and then you have to do the scoop export. Okay. Unlike import, where it gives a lot of flexibility using query, where, etc., you can actually capture delta based on a timestamp or based on a sequence field. In when it comes to scoop export, there is no out-of-the-box solution. You have to at least work with two different technologies. One is Hive or Pig, and then other one is Scoop to export the final output into the reporting layer. It is very, very, very important. You might get question on Scoop export about how to get the delta at the time of designing your application, and you have to make sure the dependency on the data processing layer to stage the delta and use Scoop to export the delta. Okay, so that's why I have been using Hive, because people and also for the delimiter purpose, to explain you the relationship between the Hive delimiters and the Scoop delimiters, I have used Hive table for the Scoop export, and also to make sure you recollect that a Hive table is nothing but a HDFS directory from which you have to using which you can export the data. I am emphasizing Hive here because you already have gone through the Hive, so you will easily relate. Okay, so any questions here? When it comes to Scoop export, it's very simple. There are very few options compared to Scoop import. Scoop export have very few options and very easy to understand. And the complexity is to build the end-to-end application using different technologies. That's where the complexity lies. Otherwise, all the fields are pretty straightforward. When I say field, all the control arguments that you use as part of the Scoop export are pretty straightforward. You can easily understand by going through the description of that argument. Okay, so if you have any questions, you can ask. Let me recollect a little bit on delimiters in a moment. If you have any questions, I will take those things and I will talk on. Actually, I already covered delimiters, so there is no need to talk on this. And then file formats, I have already covered. So we are done with Scoop. We'll move on to the next topic. If you have any questions, I will take. Otherwise, we will move on to the next topic. So I cannot take the questions on the YouTube live session for these things. This is a paid session, and I forgot to disable the live chat. Typically, I disable it. So I cannot take questions at this time. If you are interested, wait till the last moment. I will explain at that time. Samyukta have asked a question on uh, YouTube live chat, which I will take towards the end of the session. Okay, so let's move on to the next topic, HBase. So HBase is a NoSQL database, NoSQL data store. First, we'll go through setup and architecture, command line interface, and web interface. We will look into the DDL operations, CRUD operations, and I will explain a little bit on data modeling and CLI commands, and I will point you to simple Java program performing CRUD operations. Okay, so these again, I will not be deep diving into it, but you will understand quite a bit of stuff because all of you are experienced professionals. So I will try to explain in contrast with the relational databases where the NoSQL comes into picture, and also I will try to compare HBase with Spark or MapReduce. Okay, so let's start with the setup and architecture. So let me open a PPT here because I have not updated this one yet. I'm working on the lab and it's taking a lot of time to get the lab up and running. But I will be updating this material very soon. Yeah, this is the PPT. I will share this PPT with you if you are interested after the session until I come up with the content. So first we need to understand the architecture. Okay. So let us understand the HBase cluster, how it will look like. And then we will get into the tables, key spaces, column families, and columns. Again, it's about the data architecture. I will give a brief overview about how the data will be stored and how the data is managed. Okay. So if you recollect, or I might have mentioned as a statement at some point, HDFS is primarily for too few large files. So your file should be large enough to leverage this distributed computing framework. Okay, when the files are large and when you try to do the processing, even though you are doing in a distributed fashion, you are typically doing in the batch mode. You are not doing in the real-time mode. Okay, so so one of the limitations using HDFS or one of the limitations of using MapReduce or even Spark is if you have a type 2 dimension. Okay, if you have type 2 dimension, which means sorry, not type 2 dimension, type 1 dimension or type 3 dimension, where you actually update the data on the source and you want to update on the data in HDFS. Okay, so you cannot issue commands like update to update a given record. For example, right, if you have a 1 terabyte of data and you store into HDFS and you realize that some of the records are corrupted and you want to fix those few records which are corrupted out of 1 terabyte. There is no way to get into the file and fix those records. You have to fix on the source and then you have to reload the entire 1 terabyte data set. That's the limitation about using HDFS in MapReduce or Spark mode. Okay, so that being said, using HDFS or Spark, we cannot use the cluster for any operational use cases. So if you go back to my big data introduction session, I have given an example about Amazon, okay, where you search for a product and it recommends the related products at the bottom, okay, by different affinities. They call it as affinity. The affinity can be a category based affinity. Typically when you buy one electronic item such as a TV, you end up buying other electronic item. That is called as category affinity. And then there is a price affinity. So when you buy a premium TV, you will try to buy a premium music system or premium furniture. So that is called as price affinity. So there are different types of affinities, and based upon affinities, it has to recommend. So the key is the product ID or SKU number for your TV, and the values are the recommended products. Okay. So if you want to build such type of platform using MapReduce based tools or Spark based tools, it is not possible. That's where the NoSQL databases comes into picture. One of them is HBase. You have Cassandra, you have MongoDB, and there are n number of NoSQL databases. But the underlying design considerations are same. Pass a key, get the values as quickly as possible. Okay. So to facilitate that, first the data has to be indexed on the key, and it has to be distributed. So it has to sit on a multi-node cluster. So let me show the CloudX Lab environment using Ambari. Let me explain how the HBase is configured, and then we will talk about the architecture, all the architecture components. First, we'll try to understand the infrastructure, then we'll get into the data architecture, how the data is stored in HBase, etc. Okay, so now if you click on HBase, so you can see there are two region servers. I will explain what is the region server, and then a active HBase master and a standby HBase master. Okay, so region servers are the ones which will actually store the data physically. So when it stores physically, and the data will be stored in HDFS. So if I go on to the cluster and run Hadoop fs-ls, probably apps, there is a directory called HBase. So the ultimate file system data will be stored persistently is HDFS itself. Okay, then you might get a question: HDFS is not designed for this kind of stuff. Then how HBase is handling by managing files in HDFS? So that's where this region server will come into picture. There will be a memory structure. Okay, so when transactions happen, data get into the memory. So let me get onto the whiteboard. Let me get my tablet. So I'm connecting my tablet. Just give me a moment. So this is, let me check, get the proper pen. So this is our HDFS cluster. We have data nodes where the data will be stored. Okay. And on the data nodes itself, we will have data nodes for the files. We will have node managers for our yarn to execute the MapReduce programs. And when we set up HBase, we will have something called region server on each of these slave nodes. Okay. So when it comes to region server, we need to configure memory for each of these region servers. Okay. So what will happen is when we try to load the data, instead of directly getting onto the data node, the data will be first inserted into the region server memory. Okay, and there are some memory settings which you need to understand based upon what is the what is that memory size which will be used in region server. So I think by default it is 16 MB or something. I do not remember exactly. So this is for each table. Sorry, yeah, 16 MB is the memory, and then whenever you try to insert the data into a table, so data will go into this memory. Okay, data will go into this memory, and whenever 80% threshold is reached, okay, from the memory. So as data is being written into memory, the writes are pretty fast. You don't have the problem of HDFS because you are not updating the HDFS yet. You are only writing into the memory. And then when this 80% threshold is reached, okay, what will happen is it will get the data from this memory buffer and copy into something called SS table. We'll come back to SS table at a later point in time. So SS table is a file structure. This is memory. SS table is string sorted table. It stands for string sorted table, and it's a file structure. Okay. So until this threshold is reached, you will not have any data in the file system. So what happens if the memory, if the node crashes before this 80% threshold is reached? You will be data will be lost. To avoid that, there is another file structure which is local. It's not HDFS. This SS table will go to HDFS, but there will be a local file structure called WAL, which stands for write ahead log, which is similar to commit log in SQL Server, redo log in relational database, etc. So as the data is written into the memory, data will be written to the write ahead log also. So in case if it crashes, we can actually use this one to recover. So that is the purpose of write ahead log. But it will be used only to write once, and if it will be used only for the recovery purposes. Other than that, this write ahead log will not be used at any other time. So SS table is the file structure whenever thresholds reached, and it will go to the HDFS. Because this is 16 MB memory, you might end up with too many small files. Okay. So for a given table, there can be too many small files. And what happens is HBase have something called compaction. What this compaction will do is, again, there are two types of compaction: minor compaction, major compaction. I will not get into details at this time. You can explore that later. But you need to understand that these SS tables might end up as small files in HDFS, which is not good for HDFS and also for HBase. When you try to manage huge chunks of data, if you have too many small files, it will have some performance implications. For HBase as well as HDFS purpose, these small files will be compacted into large files at periodic intervals. It could be a day or it could be a week, depending upon certain thresholds. The smaller SS tables will be merged into. So already the files will be sorted by key. That's why it is called a string sorted table. So and these SS tables will be sorted on a given key. Okay, and based on that key, it can actually do the merge sort, which is very efficient to merge the sorted data in a linear scalable fashion, and then it will create this larger file, and these larger files will be the ones which will be persisted in HDFS as long as we have the table. Okay, if the delete happens, it will remove the data physically whenever this whenever these compactions happens. So compactions is the one which will take care your data in a file system in a reliable fashion. Until then, uh, as the data will be buffered into the memory, and memory will be used for serving the clients, the writes will be fast. For reads also, there will be another cache, using which data will be read faster. Hence, even the reads are much faster compared to HD, MapReduce based solutions. That's how HBase works. Okay. So now going back to the slide, I will cover tables or key spaces a little bit later. So I have covered what is a memstore. So memstore is nothing but this buffer where the data will be written into the memory. Write-ahead log. Write-ahead log is primarily for the recovery purpose. As the data is being written into the memory, before flushing into HDFS in the form of SS table, if it crashes, there should be a mechanism where data can be recovered. That's where the write-ahead log comes into picture. And SS tables, yes, SS table is a H file, yes. Spring sorted tables are the ones which will actually get into the HDFS file system, and they will be merged into H file is a class name, SS table is a industry standard term. Okay. Uh, and SS tables are the ones which will be stored in HDFS. They can be pretty small, and those small files can be used as minor, and those small tables will be merged into larger files. So smaller files will be merged into larger files, as part of the compaction. Okay, there is a question about write-ahead log. So let me explain. Let me first check the question once again. Can you explain write-ahead log? Okay. So you have, I have to change this. Don't think too much about write-ahead log. As long as it is used for recovery purpose, that is good enough for the developers. Anyway, I will explain. So you have the memory. So this is memory. And let's say there is no other structure, and it is directly flushing into SS table. You can configure that way also. If your data is not critical, and if you are okay to lose some of the data, you don't even need to configure write-ahead log. But typically we will configure write-ahead log. So let's take only the memory situation. At T1, you load few data, and then at T2, you load few more records. Okay. So the memory will not be flushed into file system which is SS table at regular intervals of time. SS table will be created or updated with this data only when certain thresholds are reached. The thresholds can be the amount of memory which is already filled in the buffer, or it could be the time. So based on the certain thresholds, it will try to flush into SS table. Now, let's say still the data is not memory thresholds are not reached for memory. At some point, before it reaches the thresholds, let's say the node crashes, the node is gone. If the node is gone, then the whatever is in memory will be gone. Memory is transient or volatile. You cannot recover it anyway. That's where the write-ahead log comes into picture. So whenever you see this term log, okay, it is typically a file structure. Okay, when it comes to file structure, it is persisted beyond the restarts. So even if you restart, once it is there in the file structure, it will be preserved. So to handle this situation, so when you actually load into the memory, at the same time, there will be a file structure which can be recycled. Means, for example, at T1 you load some data, and at T2 you load you add more records. So whenever it is written into memory, at the same time it will be written to the file structure also. Once it is preserved into file structure, then only it will be considered as commit. And this log files, when it comes to HBase, we will not be pointing these log files into HDFS. Instead, we will use the local file system of the underlying server. Okay. No, that's what I'm saying. It's a local files structure. I mean, the file will be stored in the local node itself. And so the problem this write ahead log is trying to solve is, if the node restarts, then the data can be recovered. Okay, it's not that if the node crashes, if it does not come up, uh, as long as you multiplex the log using RAID configuration, etc., you will be able to recover. Otherwise, you will not be able to recover. Okay, typically it is local file system. It will not be replicated. I will double check whether there is a mechanism to configure replication if it is desired, but as per my understanding, it is not. Anyway, so the purpose of the write ahead log is to create a file structure to support the memory in case if the node restarts or if the node crashes. We can recover the data whenever node comes back up. Okay, so that's the purpose of write ahead log. It's a file structure supporting the memory before data is flushed into SS table. Once it is in SS table, you don't need to you can ignore this data. We don't require this data in the write ahead log. That's why it will be in a recyclable, I think they call it a circular log file or something. It will use the same files to circle back and load the data again or something. I do not remember exactly. Okay, anyway, don't think about write ahead log too much. It's an industry standard procedure. Even if you think about Oracle, you have redo log, which does the same thing. If you think about SQL Server, it have commit log. So you just need to have you understand there's a term called write ahead log, which will help recovering the data in case the server is restarted or server is restarted. Yeah, and then compaction is to merge the smaller SS tables into larger SS tables. No, again, if you look into this, I think in Cassandra also they call it as write ahead log. Mem table, it has mem in that, which is nothing memory. So mem store is the counter for mem table in Cassandra. Write ahead log is to support the memory in case if it goes down. And Cassandra, I think, does not use the write ahead log. It uses a different mechanism altogether. Okay, so don't mix up and get confused. Cassandra uses a different architecture altogether. It does not use write ahead log. There are I forgot the term. So if you are okay to for the data loss, you have to configure that in. I forgot. There are three values: 0, 1, and 2. And unless anyway, don't. I don't want to get into Cassandra at this time. There is no write ahead log as per my knowledge in Cassandra. It manages a little bit differently. It uses the replication factor and all those things. Okay, so let's move on. So let's talk about tables or key spaces, and then column families and columns. That is data architecture. So far we have covered the architecture of HBase. We have masters. Typically, there will be 3 masters, not 2. In this case, they've only configured 2. And then region servers will be running on all the data nodes in the cluster, as I have shown here. So you will have data node, node manager, and region servers sharing the resources. Data node is to store the data. Node manager is to run the MapReduce jobs or Spark jobs. and regional server is for HBase. That is the architecture of HBase. Now let us launch the HBase by running HBase shell command. HBase shell. Okay. So unlike in RDBMS, we will not store the data in the form of tables or columns. We name it as uh, I forgot the term. We call it as key spaces, column families, and columns. Okay, don't try to relate tables to tables, columns to columns when it comes to HBase. So let me demonstrate a little bit here, and then you will understand. Okay, to get the help, you just type help and hit enter. It will give all the commands, valid commands which you can use. Okay, and then DDL will give all the DDL commands. So it has alter, create, describe, etc. Okay, list is the command which will list all the tables. Namespace is if you want to group tables in a namespace, we use namespace. So we'll start with the namespace, then we will create we will use create command to create the key space, and then we will go to the DML to understand what are several DML options that are available to load the data. Okay, so to create the namespace, you have to use create namespace command, and here I'm trying to create the namespace using my user ID, which is training8634. Why? I think I should not use the semicolon at the end. Okay, help create namespace. No, the syntax says create underscore namespace. Okay, anyway, list. There are many tables. So let me say create namespace training 8634. Undefined. Okay, I know what is the problem. I have to give it in the single quote. Yeah. Okay, namespace already exists. Okay, let me. Okay, there is one table called endorsements in this. Okay, so this is the namespace, and there is a table or key space in it. And let me create a new one. To create the table within a namespace, you have to use the namespace prefix like this. So again, you can actually type help to get the help for the commands. So create is to create the table. So create table name. First, to give the table name, if you want to use the namespace, you just have to give the namespace name and then demo. And it requires a column family name. Okay, I will explain what is the column family in a moment. Here I will be creating two column families, CF1. Let me take a little bit more relevant example. Let us create an employee table called EMP. Okay, and then I will create a column family saying details or D. It's better to give short names rather than bigger names. So D for employee details. Uh, Let me say employee details, ED for employee details, and then department. Okay, so this is the key space name with two column families. It has employee details and department. Okay, and if you're familiar with the Oracle standard demo database, it will have employee table and department table. Department is a parent table and employee is a child table. Okay, so when we actually use HBase, we typically any NoSQL database, we typically use denormalized data models. We don't have too many tables because HBase or any NoSQL database are not very good at joins and all those things. Okay, and it is not required for the recommendation engine. All we have to do is once we pass the employee ID, we need to get the details about the employee. And as the data is stored in the form of column families, the compression rates are very high and the performance will be much better because data will also be sorted and distributed. So when we actually insert a lot of data into this table, data will be automatically distributed onto multiple nodes in the cluster and data will be sorted by key. So the lookups will be pretty fast. Okay, now to copy the data, first we need to give the table name, which is training 8634 EMP. We can give alias also. We can alias this one into some other name, and the command to create the alias is I think it would be under tools. Yeah, never mind. I could not get it. There is a way to alias. Okay. Anyway, we will be using the full table name. And then in the column family employee details, I would like to store. First, we have to give the row ID. I will explain what is row ID. So we are trying to insert data for the employee ID 1. So this is employee ID. So now in the employee details, again I am giving the this is column family name and I have to give the column name. I want to store ename. Okay, and the ename is IT varsity and address, and you can store as many fields as you want, and you can only um, insert one cell at a time. This is called a cell. So here we are only loading a value for one column for this row key and hit enter. Now the data is loaded. So to get the data, whatever is loaded, you can run scan command, scan training 8634 EMP and hit enter. You can see it has returned one row and we have only one column at this time and value is IT varsity. And another important thing is timestamp. Okay, so if I actually do the put command again and try to do IT varsity into the same column and scan the data, the data will be updated automatically and you can also get the history of it. So there is a way to control how many records you want to keep as part of the history. I think default is 5, and then to get all the details, you have to pass certain additional arguments to the scan command to get the history. Okay, so anyway, right now we have one row, and that one row have only one column, and that column's name is ename, and the value is IT varsity. Now I want to add one more. So the second one is salary. Okay, and as I am unemployed, I will be giving it as 0. Okay. Okay, and then probably what else employee will have? Address, WebEx. Okay, now if I run scan command, you can see even though it is showing in 3 different lines, it's a one row. You can see the output here. Okay, unlike in traditional RDBMS where you insert several columns in one shot, here we are actually um, inserting one column and one column value at a time. Okay, so let me take the question from Ramesh. Yeah, we are adding one column family and one column within that column family. Okay, now if I want to add department, if I want to add the department details. Okay, so in the put command itself, here department column family is D, and let's say we have department name, LMS, and then department also will have address, Digital Ocean. Okay, now if I run scan command, we get rows from department column family and employee details column family also. So here what you need to understand is, even though we are storing data in random order, so for example, I first inserted the employee name, then salary, then address, and then department name and address. But when you see the output is actually sorted by the column name, even within this record. Okay, the column name, the data is already sorted by the column names, and then we are getting the values. This is how it will be stored even internally in SS tables when they actually stored in HDFS. Okay, after compaction, the final files also will store the data in this order. The reason is we can have a lookup based on a row key. Again, rows will be sorted. For example, now I will insert another record. In this case, it will be 3. Okay, and I want to have employee details name as PG. Okay, and then I will be creating one more with a 0 as the key. DVG. Okay, and now if I do scan, you can see data is automatically sorted. And if you have too many records, it will be even partitioned or distributed. Okay, I could not recollect the default partitioning algorithm. I think it uses the range partitioning. And means if you have 1 million records, and if you have 4 nodes in a cluster, 1 to 250K will go to one node, 250K to 500K will go to another node, etc. So it will automatically distribute it and it will automatically sort. Okay, the purpose of this is, if you actually try to fetch based on a key, row key, this is called as row key, and this is called as column key. Column names are also called as column keys. There is a reason why they call it as keys, because the data is sorted by the column name. We can also apply certain advanced filters where you can give the ranges on the column name. So there is something called, I will cover a little bit of those details as part of the next class when I talk about the data modeling in HBase. But for now, just understand that data will be sorted by row key. So this is row key. This is 1 minute. This is row key. Data will be sorted by it. And then within each row, data will be sorted by the column names. Just keep that in mind. We will talk about this in detail when it comes to data model, the significance of that in detail when it comes to the data modeling. Now we are able to scan. Scan is like select star from without any filter condition. Okay. You can also apply filters in such a way that you scan some range of values. So you have 1 to 1 million. If you want to get data from 100 to 1000 and do some processing on that data, you have to use scan and you have to apply filters on the row keys. So scan is either to get the entire data set or to filter on the row keys. You can only do the filters, range based filters on the row keys using scan. If you want to look up into this table and fetch one record at a point in time, then you have to use get command. Okay. So training 8634 EMP, and I want to get data from 1. I have to give the column family. No, I have to just give the row key, and row key have so one have 5 cells or 5 columns. So this 5 rows is not actually about rows. Actually, whatever is the number of columns that are being returned, it is reporting as 5 rows. Ideally, they should have mentioned as 5 columns or 5 cells or whatever it is. Okay, so you can get the data from all the columns for a given row using the get command. So put is the command to insert or update the data. Scan is to scan the complete data set or apply range based filters on rows, row keys, and get is to look up based on a single key at any point in time and get the column values from it. Okay, and then you have delete to delete the data also. No, I have inserted, I have given the values. It's a unique key. So employee, this is, you can think of it as an employee ID. So this, I am inserting those values. Okay, so all the 0, 1, 3 are just unique values for each employee. Okay, so now if you want to delete, you can use delete command. You can go to help, just say delete, give the column family and the column, delete. Let me demonstrate. Delete, our column family name is, our table name is training 8634 EMP, and let us delete for row key 1. If you say 1, everything will be deleted. Okay, I think I have to give the, okay, I can only delete one column at a time. I cannot delete the entire row. Yeah, so here I have to give the column family name. The column family name is, let's say I want to delete salary. Okay, so ed salary, it is deleted. Now if I run get, I will only get four values: department address, department name, employee address, and employee name. This is how you can delete. You can delete only one column at a time. Okay, and then, so these are the CRUD operations. I have covered put, which takes care of insert as well as update, scan and get, to get the data, which means to query the data. You might be familiar with this CRUD, which means create, read, update, delete. Create is insert. So for create and update, we use put command. For read, we use scan or get, and then delete to delete the data. So I have covered CRUD operations so far, the basic operations. And then if you go to the help and let me check for filters. Yeah, show underscore filters. Show underscore filters and hit enter. I don't know how to come out of it without exiting. Anyway, let me see. So show filters and hit enter. So these are different filters which you can use. Okay. So row filter is if you want to use scan and apply the ranges, you can use row filter. Within the within each row, if you want to apply the range logic. So for example, the column names are also sorted in ascending order, right? So if you want to apply range logic on that, and if you want to get range of fields, there are several filters for that. So you need to go through these things. I will not be covering these things as part of this, but you have to focus on this if you want to build an application on HBase. There are several filters which can be effectively used on top of the data. If you understand the data model, you can build your application using those filters. Okay, so we will come back to that a little bit later. So we have already seen. So let us recap about HBase cluster again. It uses master-slave architecture like HDFS, MapReduce, etc. HBase uses HDFS as underlying storage. Masters for HDFS, it's name node, secondary name node. For MapReduce, it's resource manager. If you are using Yarn, for HBase, it is one or more HBase master, at least 3 in production clusters. And Zookeeper is required for coordination between HBase masters. Slaves, I have explained it already. So this is how it will look like. And the purpose of HBase, so yeah, we have already seen this. So these are the parameter files. Zookeeper, you need to configure Zookeeper, means not developers, but the administrators, when they set up the environment, they have to configure the Zookeeper. But if you use Cloudera or Hortonworks, it will be taken care automatically. You don't need to struggle much about Zookeeper. It will be taken care for you. You just need to understand that these are the parameter files which you need to look into if you have to troubleshoot some issues. And these are the files which will cover the HBase configurations. Like in HDFS, we have Hadoop pnv.sh and then core site HDFS site.xml files. For Yarn, you have Yarn site and Mapit site.xml files. For HBase, you have HBase site.xml. So if you go to the lab now, cd etc HBase conf ls-ldr. We have this HBase site.xml. And this will have all the parameters. So these are some of the memory settings. The key value max size is 1 MB. This is while retrieving the data. Okay, like that there will be HBase root directory, which will tell where your HBase files should be. Okay, and then there are several other things which you need to slowly build if you want to pursue. Means if you have to work on HBase, you need to get into the details about several parameters. You can get the same details using Ambari also. The way we have seen for MapReduce and HDFS earlier, the same way you can go to the config section of Ambari and you can get the details of most of the parameters. And then HBase shell can be launched using command line interface. And there is a web interface also. And I don't think CloudX Lab provides you the access to the web interface of HBase. For developers, it will add some value to understand what all key spaces you have, etc. But you don't need to use on day-to-day basis. DDL operations I have already seen. I have already shown you creating the namespaces, create tables or key spaces with column families. No need to define columns when you create the table. I will explain why once we get into the data modeling. We can truncate the key space. To drop the key space, we have to disable and drop. We cannot drop it directly. Okay. So truncate will delete all the data from the key space. Disable and drop, it will disable it, and it will we have to run disable command, and then we have to run drop command. So CRUD operations are already covered. Now let's get into the data modeling and why the data is sorted based on the column name, and how you can use that feature effectively. Okay, so if you look into this data, okay, scan finding 8634 EMP. Okay, if you look at this data, if you see employee ID 0 have only one column, employee ID 3 have only one column, and employee ID 1 have 4 columns. So the reason why we have to insert one cell at a time is HBase or any NoSQL database takes few things as part of their design considerations. One, each row attributes can be different. So let's take the example of our endorsements, LinkedIn endorsements. If you go to the linkedin.com and if we go to the profile and go to endorsement section, okay, we go to endorsement section and you can see I have a lot of endorsements. Okay, let's take one guy randomly. He's relatively young, and okay, I think I cannot go from here. I thought I can go. Let me take Minesh. Okay, and if you see, his endorsements are significantly different. Okay, LinkedIn, you can add up to 50 different skills as part of the endorsements. You cannot go beyond that. Okay, so if his data is significantly different from my data, so if you have to model this in traditional RDBMS, how you will do? You will have ID for each record, and then endorsee name or endorsee ID, which is my ID. If it is my record, it will have my ID, and then endorser name and endorsed technology. Okay, so these are the things which a traditional RDBMS will have: ID, endorsee name, and endorser name. Whoever endorses me, their names will be there, and the technology on which it is endorsed. So if I have 50 different skills, and on average, let's say I have 50 endorsements for each, or even 100, I might have even more. So let's say we have 100 endorsements for each on average. So 15 to 100 is 5,000. I have 5,000 records. Means my ID means uh, my name should have 5,000 records. Minesh might have only 10 on average, which means he will be having 500 records in the database. Okay, and if we have to generate this report for a platform like LinkedIn, where millions of users are there, at runtime, if this report has to be generated, it will take enormous amount of resources, and scalability will be a constraint. Okay, and on top of that, let's say as a recruiter or a hiring manager, I want to get all the people who are endorsed on a particular technology. Okay, and then I want to get whoever is endorsed most on top. That means I have to sort the data based on the technology and based on number of endorsements, and then the names. I need to get the names in the descending order based on the number of endorsements. Again, there is a lot of crunching that needs to be happen. Okay, so but if the data is already pre-sorted like this, and for example, in this case, I have the column name as endorser. Okay, so all the 5,000 rows will be part of one row key, which is my row key, and it will have all the 5,000 records. Column name could be endorser, or what is the other one? Endorser name and endorser technology. So column name could be the endorser name. So if it is endorser name, and if the value is technology, if I have 50 different endorsements from that person, the value has to be a list. We cannot store it as a string. We have to have the list, which will have all the 50 records. Or we can have a column family name. It's within the column family itself, name itself, we can actually prefix with the employee name itself as a column name, or endorser name itself as a column name, and then the technology. So for example, I can also say put training EMP IT, and then I can use some type character also, Oracle, and then I can just put a placeholder over here. Okay, there is some syntax issue. No. Okay, yeah, I got it. Sorry, I didn't pass the row key. Thank you. I can have a delimiter here. Okay, I understand what is the problem. Okay, now if I run scan, we can see this additional value. Here I am getting special characters because I have hit enter twice and then close it. So let me fix it. Okay, now you can see my column family ED have column name like this. Okay, so the first one is endorser name, and the second one is the endorser technology. So if I have 50 such technologies endorsed by that same person, uh, it will have his name in it, and the data will be sorted. So all the IT, all the rows which will have this IT field will be will be grouped together. So I can write filters effectively to extract data. It will go to my row, which will have 5,000 records. In that, I can apply the range scan, and I can fetch the data in quicker fashion. Okay. I'm sorry for that. Okay. So that is the rationale. Now, if you think about it, I have 5,000 columns with different names. If there are 5,000 endoses or endoses in my list, and someone else have 1,000, okay, and the column names are significantly different, but we can use this similar logic to fetch the data based on a skill or whatever it is. So that is the rationale behind sorting the data, so that we can apply the range filters within the column within the columns in the column family. So when it comes to data modeling, there are two ways we can do. One is thick data modeling, and the one is thin data modeling. Okay, in this case, if I have 5,000 rows for each row, sorry, 5,000 values for each row, by looking up with my just row key, I have to get 5,000 records, and then I have to process it. That is a thick column family, which means the column family have an 5,000 can have 5,000 different columns if I design this way. Okay. Thin column family is my column family size will be smaller, and the way I can manage by using thin column family using the same data set is by doing this. Put finding 8634 EMP. Here I want to use some delimiter, and in this case, let me give the technology. Let me use the technologies rather than the names. So here I have the row key. So this is my this is endos ID. This is the technology which is being endorsed, and then ED endorser name can be whatever it is. Let me name it as Durga and hit enter. Now the record is inserted. Now if I scan 8634 EMP, you can see it here. Okay, and if I have 5,000 as we can have up to 50 endorsements, there can be 50 different records, one for each sorry, when I say endorsement, 50 technologies that can be endorsed, or 50 skills that can be added as part of the endorsements. We can have 50 different records, and for a given employee, if I need to get the details about the endorsements for a given skill, then I can actually create a key like this, and I have to only get all the records associated with it. If I use this approach, I have to go through 5,000 records or 5,000 columns and values, and then process it, and then get the information if I use this approach. Okay. If I use another approach, where I have the technology and then give the list of endorsers. Let's say 50 endorsers are there. So endorser 1, endorser 2, endorser 3, etc. And E1, E2, E3 are endorser IDs. If I have like this, then if I where is that one? So this is I am looking for a record which have Oracle in them. Then we have 50 columns, and each column will have a list of values delimited by particular field. So we have to go through go to the column family, and then we have to do the necessary processing to get all the details for a given technology. So you can organize the way you want. So the worst case, so I don't know what is break. What is that, Gayatri? I didn't get you. We'll be done within no time. We are almost at the end of the session. Okay. So this is called as thick column family. Okay, if you store data like this is called as thick column family. So what I'm trying to say is, sorry, for our example, it will be like this. So this is the endorser name, and this is the technology which is being endorsed, and this is just a constant value which we are giving. So this is a thick column family. For each and every row key, there will be 5,000 columns if we design this way. If we design this way, for each and every row key, there will be 50 different columns, and each column will have a array of values of endorsers. If we design this way, for each technology, if you are giving endorser's name here at the column name, and actually we should not do this. We can directly give the name here, endorser name here, and value as just placeholder. For each endorser name, we will have one column added. Okay, but if you want to add other information, so you need to understand these features, and you have to come up with a design of your data model based upon your requirement, whether you want to use thick column family like this, or this is the thinnest column family for this use case, wherein for each skill we have a separate record and have the details about that skill in our table. Okay, so very important to understand this data model. If you don't understand this, then you will be making all kinds of mistakes. Especially you will bring your RDBMS skills onto the table, which will lead into the confusion. Okay, and now when it comes to LinkedIn, what they do is, instead of using a table the way, so there will be a raw table. As part of the raw table, they decide whatever design they want to, where they will capture all the details about endorser technology, endorser name, and then there will be a aggregated key space. Okay, so the aggregated key space will look like this. So let me create a new table. Create training 8634 EAG, which means aggregated endorsements. Okay, and then column family name, and hit enter. Now you have the table. Okay, now when we insert the record, the aggregated table will look like this. Aggregated names key space will look like this. So CF1. So each individual can have 50 different technologies, right? So the column can be the column name can be either the technology name, in this case Apache Spark, Oracle data warehousing, etc., or the count, whatever they want. By having count, if they want to sort the data in descending order, it will be better to have it by count. Otherwise, if they want to give the flexibility, it's better to have the skill as the column name. So in this case, let's say Apache Spark. So this is an aggregated column family, aggregated table which we are trying to create. So this Apache Spark have 37 endorsements. Okay. On top of that, this report also show the latest few endorsers pictures, right? So how many? 4, 8, 12 of them. Okay. So there will be, okay, here I have to give the ID. So let me give the ID here. Okay. On top of the total number of endorsements, I need to, they will store, means if they decide with, if they design with HBS, this is how they will store. They might have be using some other technology, but if they're using HBS, this is how they will store. This is how they can store, not they will, they can store. So here we will give the CF1 endorser 1, and value is whatever ID it is, 1. Okay, I can only store 1 at a time. Okay, so this will look like this, and then like that there will be 12. Okay, so now if I scan, okay, and now if we scan, first we got the count of the endorsed technology. If you want to add more technologies, we can add that also. So I have, I think, around 200 for Oracle. Okay, and then I will have the latest 12 of them as part of this collection. So these columns, so ED1 will have the latest one, ED2 will have one but latest, ED3 will have two but latest, etc. There will be 12 fixed fields. Okay, so for each technology, we have 50 technologies, right? So for each technology, you will get the count and the latest endorses details. Only 12 of them, which will be recycled whenever a new person endorse on a particular technology beyond 12. The list will be refreshed, and this will be used to generate the report at the runtime. So whenever someone visit my profile, the request will go to the table which look like this. Okay, which will have all the pre-aggregated information. But when someone endorses me, it will get into the raw table, and then there will be a synchronous process which will be doing these analytics and preload the pre-process the data and load into this aggregated collection. Okay, so that is how it uses. So we will have different levels of collections or tables within HBase itself, depending upon our requirements. So first you need to understand the requirement, and you need to understand the capabilities and limitations of a technology, and then you have to come up with the design, and then you have to implement the solution. Okay, so that is about the data modeling when it comes to HBase. I have already shown you a command line interface for put, get, scan, and I have briefly explained you about filters. As part of the next class, we will start with developing Java programs. I will explain how to do CRUD operations, atomic operations, and batch operations with Java program also. I will not get into too many details. I will just explain what are the classes that needs to be used and how to write a simple Java program to perform these operations. Okay, and I will not be covering integration with HBase and Hive, but HBase is capable of for integration with MapReduce and Hive. So if you have the data in HBase, you can write your MapReduce programs, as HBase has one input format. And if you have to do the batch processing, you can use MapReduce. I will explain the rationale when to use MapReduce or Hive on top of HBase, but I will not be demonstrating how to do that. Okay. So any questions before we wrap up for today? I will send the PPT. So I will give few seconds. If you have any questions, you can ask, and then okay. So for some people, Vishal, um, probably yes. Anand's internet seems to be slow. That's why uh, you might not be getting good clarity. You might not be getting good clarity. Anyway, so there was one question from Samyukta. The question was, if you are using the same database, I don't know what does that mean. The second question is, in EXPDP in Oracle, we are using parallel, which are taking backup concurrently for tables. Do you have any such feature here for doing this in sequential? I'm not sure. So you need to first, yeah, there is a way. If you want to just do it in sequential fashion, you just have to use number of mappers as one. Anyway, we will. You can post your questions in the comment section, Samyukta, and I will try to respond to it. From this question is not clear. I'm not sure whether you have knowledge uh, about Hadoop or not. Typically, I disable live chat for my sessions because this is primarily for paid students in my WebEx, and I'm streaming so that they can use it for reference, and also people like you can understand the quality of my training and they can enroll for my future courses. Yeah, I will. I think I already have in my GitHub account. Just post it in a comment section. I will give you the link in the comment section itself. Okay, so it seems that the WebEx guys don't have any questions. That being said, thank you very much for attending the session. We will resume where we stop on HBase, and then tomorrow we'll talk about Spark data frames, and next week we will focus on building the cluster. I will explain you how to build the cluster in a quicker fashion. Once you know all the technologies in detail, you already explored HDFS, MapReduce, Spark, Scoop, Hive, and now HBase up to some extent. So you at least have some understanding about the architecture. We will be setting up a cluster. I'll be demonstrating, and if you are interested, I will be providing lab for you as a paid service, and you can give it a try. We are working on building the lab, and I will keep you guys posted. Okay. That being said, thank you very much. Have a nice one. Bye.